Hi, hello. So welcome to another math lesson. We're going to talk about identifying ways to rewrite expressions. We're talking about the difference of squares today. Get excited. All right, so this is the second lesson of Unit 3. Here we go. All right, so during this lesson, you're going to learn how to recognize the difference of squares and be able to factor it. A lot of this vocabulary is the same as in Lesson 1 of Unit 3. We have our base, that number, variable, or expression that has a power or exponent. Right? So if I have 2 raised to the 4th power, my base would be the 2. And the exponent is the power that is raised from the base. Right here is my exponent. I have a variable is any letter in an expression that represents one or more numbers. If I have a factor, it's a number that can be divided out of another number. So say I have, let's go with 10. A factor of 10 is 2. I can divide 2 out of 10. But if I want a factorization, which is 2 or more numbers that are multiplied together to get another number, I would say, well, what times 2 is 10? There's 5. 2 and 5 are a factorization, where if you said 2 or 5 separately, that would just be a factor. We have the factored form of a quadratic, a multiplied by the quantity of x minus r1 multiplied by the quantity of x minus r sub 2. All right, we have terms, our single numbers, variables, or combinations are both separated by pluses and minuses. That's the key point there. Remember, terms can contain exponents. All right, polynomials are a function or expression that consists of many terms. We look at the prefix poly, which means many. Nomial, numbers, many numbers. Okay. Coefficient is the number in front of a variable, or variables are typically letters, or the number multiplying by the variable. Every term has only one coefficient. There's no number in front of the letter. It's assumed the coefficient is 1. An expression is numbers, variables, and operations that are put together to form a phrase. Expressions do not have an equal sign. All right, here's a list of perfect squares. If you want to take a minute to go through these, make sure that you have an understanding of them. They can help in different quizzes. All right, also remember that we can have variables be perfect squares. So x squared is equal to x times x. So if I take the square root of x squared, that's equal to x. Just like here, I have 2 2's, 2x squares. Square root of 4x squared is equal to 2x. Square root of x squared, y squared, I have 2 x's, 2 y's, so each one of those come out. All right. Now factoring the difference of squares. So some polynomials are special and can be factored in specific ways. So today we're talking about the difference of squares. It's a binomial, so it'd be something like this, x squared minus 9, okay, whose terms are both perfect squared. So x squared is a perfect squared, and 9 is a perfect squared. So perfect square, and 1 is subtracting the other. So 9 is being subtracted from x squared. All right, so here's my steps to factor a difference of squares. 1, the square root of the first term is the first term in the resulting binomial. So remember, we're factoring it, so we're trying to get it to look like something like this. So this is the first term, right? Then the second step is the square root of the second term. It's going to be the second term in the resulting binomials. And lastly, one's going to have a plus sign and one's going to have a minus sign. So I'd have a plus and a minus. And it doesn't matter which one's which. All right, let's look how this goes. So it says factor the following expression. So I have to ask myself, is x squared a perfect squared? Square root of x squared is x, right? We get x times x. 2 of them were solid, so I get an x. Now I say, is 81 a perfect square? Well, 81 can be broken into 9 times 9. 1's going to come out. A square root of 81 is 9. So it is. So my factors, I'm going to come right there. My first term in each binomial is the square root of my first one. So that's x. So I'm going to put x and x. Then my second term in each binomial is the square root of my second term of the binomial, which is the square root of 81, which is 9. Now one has a plus and one has a minus. That's my my factored form. Let's look at y. Okay, so we're gonna just distribute this. X times x gives me x squared. X times a negative 9. It's negative 9x. 9 times x is a positive 9x. 9 times a negative 9 is a negative 81. When we combine like terms, we notice that these middle terms are going to cancel out. So I just have x squared minus 81. We're good. We did it correctly. Alright. So let's look. So perfect squares are simply something that can be rewritten as one term multiplied by itself, right? So let's look at some other types of perfect squares. X to the fourth equals x squared times x squared. So the square root of x to the fourth would be x squared. Notice that when I have a even exponent, those are the ones I can take a square root of, and it's just half of them. So like the square root of x to the 6, like we're showing here, half of x to the 6 would be x to the third. There's my perfect squares. So notice it needs to be an even number. So when finding the square root of the term, simply divide the exponent in half. And that will tell you what the square root is. Alright, so here is an example. Is finding perfect squares. Is c to the 8th a perfect square? If so, why? Well, c to the 8th is equal to, we want to take the square root of c to the 8th. So that'd be c to the 4th. C to the 4th. I have some number multiplied by itself one more time. So that would give us c to the 4th. We would say yes, it's a perfect square. Now let's look at a squared minus 8b squared. Can I factor this? Is a squared a perfect squared? So can I take the square root of a squared? That one works. How about 8? Can I take the square root of 8? Let's see. Nope. So that one doesn't work. B squared works. Because I can't take the square root of 8 and get like a whole number, positive whole number, I would say this one does not work. What about this one? Can I take the square root of 9? Yep, the square root of 9 is 3. Can I take the square root of x squared? Yep, square root of x squared is x, so I'd have 3x and 3x. Square root of y squared, we're good there. We get y and y. 1 plus, 1 minus. Okay, so for these next few, we're going to do like 2 more. I want you to pause the video, see if you can factor these. All right, so y squared minus 144. So I'm going to say y squared. Yep, we can take the square root of that. It's y and y. Square root of 144, we definitely can. 12 and 12. One's a plus, one's a minus. There's my factor form. Lastly, can we factor this expression, x squared? Yep, so we can say x and x. Can I take the y squared, y and y? But notice something here. I have a plus. This would be the sum of squares. We've been talking about this difference of squares. So a lot of people will want to say, well, isn't it just plus and plus? This doesn't work, and let's look why. If I go x times x, I get x squared. X times y gives me plus xy. Y and x there is plus xy again. And y times y gives me a y squared. Now when I combine my like terms, I get x squared plus 2xy plus y squared. This doesn't work. I need these to be different signs so that my that middle term here is going to cancel out. These two right here, I want them to cancel out so I can be left with a binomial up top here. All right, if you have any questions, please come and contact me. I'd be happy to help you. Have a great day. Thank you.